In this video, we are going to be talking about triangle similarity. So we're shifting gears a little bit from triangle congruence, and we're going to be talking about something new, a new definition. Now, by definition, two triangles are similar means that they don't have to have the same size. Like one can be bigger, one can be smaller, but they do need to be the same shape. Now, there are two major conditions for similarity. The first one is that corresponding angle measurements must be congruent. The second one is that corresponding sides are proportional. So we're going to talk a little bit more about what that word proportional means. But for now, you want to make sure you understand notation. So the notation for similar triangles, it looks like a little squiggly line. It almost looks like the top of a congruent symbol, just a little squiggly like this. So that means triangle ABC is similar to triangle DEF. Now, just by knowing that, using our definition, we know that all corresponding angles are the same, or that they have the same measure, or that they're congruent. So angle A and angle D are congruent. Angle B and angle E are congruent, and then angle C and angle F are also congruent. Now, we also know that the corresponding sides are proportional. So we're going to talk a little bit more about what that means. But just make sure you understand those two major conditions of similarity. So we say that in similar triangles, our sides are proportional. Now, here's an example of what this means. So another vocabulary word we're learning is scale factor. So a scale factor is a number that all components of an object are multiplied by in order to create a proportional enlargement or reduction. So if all three sides are proportional, it means that they're like multiplied by the same number to get from figure 1 to figure 2, right? So let's see how we can show that. So first you want to look at your corresponding sides, right? So if I look at this side and this side, those are proportional, right? So if I make my ratio to represent that, maybe we'll do something like 10 over 2, right? If we do that, 10 over 5. If we do that, we will get that number of 2, right? That scale factor that is listed here. Now let's check if that number is true. If our triangles are similar, we should get that same number when we're comparing another pair of corresponding sides. So let's go here. Let's do 6 over 3. And if we do that, we do get that same number of 2. And then here, this bottom side, if our triangles are similar, it should be the same, 12 over 6. Now if we simplify that, we get 2 in all three of those fractions that we create, right? So since all of our sides are proportional to one another, we know that our triangles are similar, right? And another way to think about this would be, okay, to get from this triangle to this triangle, I multiply all of my sides by 2, right? And it can also work going backwards. You can also go from this triangle to this triangle, but in that case, you would have to multiply your sides by 1/2 instead. So our corresponding pieces shortcut is used to help us draw pictures. It's used to help us draw triangles in the same orientation if they're not already done so. So if there's no picture, you remember you always must draw one. And if your triangles are flipped around and they don't look like they're in the same orientation, you gotta flip them and make them in the same orientation. So I draw my first triangle ABC first. Now RST, remember, we're talking about similarity here, not congruence. So I don't need to draw my second triangle having the same size. I can make it bigger, or I can even make it smaller if I want to. So since A and R both come first, I know they go together. So since A is in the bottom left, R needs to also be in the bottom left. B and S both come second, so I know they go together. And then last but not least, we have C and T corresponding to one another. So this can help us identify congruent angles and also make those proportions of our corresponding sides. So are these triangles similar? Let's take a look at this example number 1 here. So let's make those proportions that we talked about in a couple slides ago. So if we look at our corresponding pieces, I'll make my first fraction 12 over 3, right? And I know that when I do that, I get 4. Let's choose another side, because remember, this ratio that we come up with, right, when we simplify, that should be true for all 3 pairs of sides. So then we have 12 over 3 again for this blue pair. And when we simplify that, we get 4. And then for this green pair of corresponding sides, we have 24 over 6. And if we simplify that, we get 4. So all of our sides are in proportion to one another. So that is wonderful. But we also we have angles here, right? So we want to make sure that all of our angles are congruent as well. So we have angle A congruent to angle D, they're both 30. Angle B is congruent to angle E, they're both 120. And then angle C is congruent to angle F, they are both 30. Now I could use 3 arcs for both of these since they're both 30. Now in this second triangle, let's do the same thing. So let's choose these 2 sides here. So if I do 5 over 15, or you know what, I'm going to use the bigger number just so it's easier for us. Because it doesn't matter the order you go in, to be honest. So 15 over 5 I'll do first, so that we can simplify it to get 3. Let's do 18 and 6. So we get 18 over 6. Now remember, I'm putting these in the same fraction because they're corresponding sides, right? They have to be corresponding. When I simplify that, I also get 3. And then last but not least, in this green color, let's handle EF and BC since those are corresponding. So I'll do 6 over 4, but when I simplify that, I can tell I'm not going to get 3. That is a big no-no. So if these triangles were if these triangles were similar, all 3 of these, just like in this example, would have to be equal to each other. But in this case, this last fraction, or that last ratio that we made of our corresponding sides, that's not the same, right? Now, without making these proportions, you could kind of use the same logic. Look at your 3 sides, right? To get from 15 to 5, I divide by 3. To get from 18 to 6, I divide by 3. To get from 6 to 4, I'm not dividing by 3, right? But it's a good habit to get into of making these proportions because we're going to have to do it in this example right here. So when we have that 2 triangles are similar, we might have to make these proportions. But in this last slide, we were making 3 sets of proportions because we had info on all 3 sides, but we might not always have to do that. So I'm going to show you guys 2 methods that you can use, and you can choose which one you like to use better. That is totally up to you. So in both methods, we're creating proportions. In method 1, what we're doing is we're taking a side. We have 2 triangles, right? Side triangle 1 and triangle 2. So in method 1, we're taking a side of triangle 1, which is NL. We're picking a side. Then in the denominator of this fraction that we're making, we're going to put the corresponding side, which is going to be UT. Then in the next fraction, we're going to pick, I should have made them both red. Let's make them both red. Then in the next fraction, what we're going to do is pick a second side of triangle 1 that we have info on, right? I'm not going to pick NM because we have no values for that. So this is LM. And then in the denominator, we're picking that corresponding side in the second triangle, which is TS. Now in method 2, we're still starting with our first side of triangle 1. So we're still going to start by writing NL. But instead of shifting gears, instead of moving over to triangle 2 in our denominator, method 2 just involves we put the second side that we're using of triangle 1. Now we're going to set that equal to, now our numerators in this method are going to go together. Like these are going to be the corresponding sides, right? So our first numerator in the second fraction is our corresponding first side. So NL and UT go together, right? And then my denominator is going to be the corresponding second side that I chose from my triangle 1, which is going to be TS. So in this method, you can kind of see the corresponding pieces go left and right on the numerator. So my numerators our corresponding pieces. And then separately my denominators are corresponding pieces. In this method, our corresponding pieces go up and down. So NL and UT, and then LM and TS. So it's really up to you how you do it. You'll see when we substitute that you get the same answer. So we have some actual values here. NL is 24 over UT, which is 18, equals LM, which is 16, over TS, which is X. Now, making these proportions are helpful here because we have a variable that we're solving for. So if we cross multiply, we'll get 24 times X equals 16 times 18. Now, I don't have a calculator, so I'm not going to solve this, but that's just algebra. Now, let's show the substitution in method 2. NL again is 24 over LM, which is 16, equals UT, which is 18, over TS, which is X. Now again, if we cross multiply, we get 24 times X equals 16 times 18. So you can see, no matter what method you choose, you are going to get the same answer. Now, it's important to know both and be able to do both because there might be multiple choice questions that give you some proportions written out, and you might have to choose which ones are correct versus which ones are incorrect. And if you don't know both of these, you might think, for example, that method 2 is wrong, but it's correct. So you got to be able to recognize both. Now, here's our last example where we have a more complex diagram. Now, I always recommend to you guys when you have a complex diagram or if a picture's not drawn for you, you want to go that extra step. Make it a little bit easier for yourself. Let's separate our triangles. So here we have triangle APW, and we're going to carry those measurements in. And then we have our larger triangle, which is AVZ. Now be careful here. This side AV is not just 4 or X. You got to add them up. So AV is 4 plus X. And then AZ over here, right, that's 6 plus 3. That's going to give us 9. So we're going to do method 1 and method 2 again. So let's try to use, I'm going to try to use colors here again. So let's use blue. So we're going to do method 1. We have a side of triangle 1, which is AP. And we're going to put that over the corresponding side in triangle 2, which is AV. Then we have equals, and then we're choosing our second side of triangle 1. Now in this case, I'm picking AW because that's the piece we have info on, right? I don't really care about PW right now. And then my denominator is my corresponding side of my second triangle, which is AZ. Now setting up the proportion for method 1, we have side 1 of triangle 1, which was AP. But instead of our denominator being a side of triangle 2, our denominator is just going to be the other side of our first triangle, which is AW. And then equals, our numerator is going to be corresponding with AP, which is AV. And then our denominator is going to be the corresponding side of AW, which is AZ. Now let's make those substitutions. AP is X over AV, which is 4 plus X, equals AW, which is 6, over AZ, which is 9. Now, in method 2, we would have X over 6 equals 4 plus X over 9. Now, if we cross multiply, you guys need to make sure you're going slow and are being precise. We're going to get 9S equals 6 times 4 plus X. So you got to be careful. You need to make sure when you expand that you're distributing that 6 to both terms. Now in this one, again, we'll get 9x equals 6 times 4 plus x. Oops. And then again, you're going to make sure you distribute that 6. And then you're going to end up having to solve for x. So again, make sure you can recognize both methods. You guys, when we practice, you're going to probably have to use both at first, but eventually you'll be able to just use the one that you see most fitting for yourself.